This session is on modify Euler's method or improved Euler's method or Euler's predictor corrector method. Please look at part 1, 5 and 6 for better understanding. We will look at how to derivate formula and how to solve ordinary differential equation at a particular point from initial condition. And we will solve one of the problem on modify Euler's method. Please like, share and subscribe this particular channel. Coming now to modify Euler's method, improved Euler's method or also known as Euler's predictor corrector method. Now if you consider the forward Euler's method, okay, the general formula that we know is nothing but y of I plus 1 is equal to y of I plus h into f of x of I comma y of I, right? And this one they would be giving you the value of y dash is equal to f of x comma y, and they would be giving the initial values. The y of x naught is equal to nothing but y naught, and they would be asking the values y of x1 is equal to how much. In this form they would be asking question. Now if you consider the Euler's method, what we do is nothing but consider the initial conditions, right? X naught and y naught, and we can find the slope of it. If you consider the slope s1, which is equal to nothing but f of x naught comma y naught, right? If you consider a graph here, this is nothing but x-axis, this is nothing but an y-axis. If you consider the function as in this particular format, okay, then if you consider this particular point as an x naught, and the value side of it is nothing but y naught, right? Now we're drawing in a slope of it. We got a slope. From the slope, we're defining the value of an x1. What is x1? x1 is equal to nothing but x naught plus h. H is nothing but distance between both of them. H is known as nothing but a step size. Right? Now we consider x1 value. If we consider a triangular format, right? It forms this triangle. If we consider distance from here to here as an a, and this is h, this is nothing but a slope s1, right? Then you would be getting one more value here, which is nothing but an by 1, right? Now consider this one. We can consider y1 is equal to nothing but y naught plus a, right? What is a? A is nothing but it is forming a triangle, so a is nothing but h into s1, which is equal to nothing but h into f of x naught comma y naught, right? This is by using a forward Euler's method. Now this is not an exact value, right? This is nothing but a predictor value, right? Y of p, but we should get the exact value here, which is nothing but y of c, corrected value. So from predictor value we'll be finding the corrector value. How do we do it? By using a modify Euler's method. It is nothing but we will be considering the value of y of I plus 1 is equal to nothing but y of I plus h into average of slopes, s1 slope plus s2 slope by 2. Okay, what is s2 slope? Is nothing but slope we get it from a predictor value. So here there is a predictor value, so we'll be drawing one more slope, right? This is a slope of a predictor value. Then value of a slope of a predictor value is nothing but we can consider this one as nothing but f of x1 comma y1, right? Now we'll be taking the average of both of them, then s1 plus s2 by 2, and we'd be getting one more slope, new slope, right? If you consider this one a slope and a s3, then we'll be drawing one more line, then the value is nothing but a correct value, yes or no? So by this one we will be finding the correct value by using a Euler's predictor corrector value. From the predictor value, right, from the predictor value we'll be correcting the exact value. So formula of it is nothing but y of I plus 1 is equal to nothing but y of I plus here h into s1. Okay, h into s1, which is equal to nothing but h into f of x naught comma y naught. When you consider this one as nothing but k1, so it becomes k1 plus, now it becomes k2, which is equal to nothing but h into s2, which is equal to nothing but h into f of x1 comma y1 plus k2 by 2. Okay, this is a basic improper formula by using a predictor deductor method. Okay, we'll be solving another problem on it. Now, general formula of a modified Euler's method or improved Euler's method or Euler's predictor corrector method is nothing but y of I plus 1 is equal to y of I plus 1 by 2 into k1 plus k2, and where k1 is equal to h into f of x of I comma y of I, and k2 is equal to h into f of x of I plus h comma y of I plus k1, right? That's a basic important formula of a modified Euler's method, where I would be equal to nothing but 0, 1, 2, so on, and h is nothing but a step size, right? Let us solve one of the problem on it. Now coming to a question. The question is, using modified Euler's method, solve type differential equation du of dx is equal to 2 cos 4x pi by 2 minus 5, where y of 0 is equal to 1, with step size is equal to 0.25, then the value of y of 0.25 is equal to. Okay. Now they are given the details that y of 0 is equal to 1. Then we consider x naught is equal to nothing but 0 and y naught is equal to nothing but 1. Right. Again they are given the step size 0.25. Then h value is given as nothing but 0.25. We have to find the value of y of 0.25. We have to find the value of y of 0.25, which is equal to nothing but y of x naught plus h. As I know, it's a 0 value, it's 0.25. So which is equal to nothing but y1 value, we have to find it out. The general formula that we know is nothing but y1 is equal to nothing but y0 plus 1 by 2 into k1 plus k2, right? By using a modified Euler's method, where k1 is equal to nothing but h into f of x naught comma y naught, and k2 is equal to nothing but h into f of x naught plus h comma y naught plus k1, right? Where f of x naught comma y naught, they are given the values f of x comma y, we know the value, which is equal to the differential equation 2 into cos of 4 pi by 2 x means it becomes 2 pi x minus y, right? So first we'll be finding the value of f of x naught comma y naught and find the value of k1. F of x naught comma y naught, which is equal to nothing but x naught is 0, y naught is nothing but 1. So it becomes 2 into cos of 0 minus 1, which is equal to nothing 1, right? So the value of k1 is equal to nothing but h into f of x naught comma y naught, which is equal to nothing but 0.25 into 1, which is equal to 0.25. Now value of k2, right? k2 is equal to the h into f of x naught plus h, so it becomes 0 plus 0.25, and y naught is nothing but 1 plus k1 is 0.25. So value of k2 is equal to nothing but h into f of, we will substitute the values here, it becomes 0.25 comma 1.25. So just substitute the values here, h is 0.25, right? Then f of 0.25 and 1.25, it becomes 2 into cos of, it is a 1 by 4, so it becomes pi by 2, is or not, minus 1.25, as or no, it becomes nothing but 0, so which is equal to nothing but minus, just multiply, it becomes 0.3125. So k1 and k2 we have to take the average of it, k1 plus k2 by 2, which is equal to nothing but 0.25 minus 0.3125 by 2, which is equal to nothing but, we get as minus 0.03125. Then we have to find the value for the y1. Then y1 is equal to nothing but y0 is 1 minus 0.03125. So just substitute the values, we get it as, now using in a calculator, we get the value as nothing but 0.96875. Okay, then y1 is nothing but 0.25, right? So the answer is 0.96875. Okay,